Hello everyone, this is the second video from the graph series. The problem that we are going to solve today, that is labyrinth. So you are given a map of a labyrinth and your task is to find a path from start to end. You can walk left, right and up and down. So what you have a grid of n cross n size and in which hash represents the wall and dot represent the floor. From floor you can go to the right, you can go to the right, left, up and down. And you have a start point and you have a uh, end point and you have to find out is there any path from A to B, right? So there are two paths. That is one of them is this, and another one is this, right? So there are two paths. You have to print the shortest path with its description. So, so this path has a length of 1, 2, 3, 4, 5, 6, 7, 8, 9, and this path 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The shortest one is this one, and you have to print its description, that is left, down, down, right, 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 and then up. So the answer is, if there is a path you have to print yes, then print its length and then its description, left, down, down, right, 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 and then up. You have to print in this way, right? If there is no path, then you have to print no. So I hope you understood the question. Now next thing, that how could you do that? You can use simple BFS, right? In BFS we maintain a visited array, right? And after apply BFS, if you found that you visited the endpoint, means there is a path. If you visited the endpoint, means there is a path, right? If it is not visited applying after applying BFS, then it means there is no path, right? It means there is no path. Now the next thing is how you are going to do print the path. How can you do that? So let's find out. So for this, you have to maintain the parent array, that the where who suppose you have to maintain that where it is come from, where it is come from. So you have to maintain the parent, whose parent is who, right? Whose parent is whom. So so you have to just maintain the parent array and you have visited array. Uh, let's understand it by trying. So you start with A, right? And from A you can go to the left. That is 1 comma 1. So you initially you have you push the start point in the queue, right? Initially you put a start point in the queue and you mark it as visited, 1 comma 2. You mark it as visited. You choose another color. Yes. And from 1 comma 2 you can go to the 1 comma 1, right? So mark it visited and where it is come from, who's the parent of 1 comma 2 is 1 comma 1 is 1 comma 2. So you stored it in the parent array. Now you push it into the queue. We are done with this. So from 1 comma 1 you can go to the 2 comma 1. So the parent of 2 comma 1 is 1 comma 1. 2 comma 1, push it into the queue, mark it as visited. Now the next is 2 comma 1. From 2 comma 1 you can go to the 3 comma 1. Who is the parent of 3 comma 1? It is 2 comma 1. 3 comma 1, push it into the queue, mark it is visited. Now from 3 comma 1 you can go to the 3 comma 2. So mark it visited, push it into the queue, right? And from this, who is the parent of 3 comma 2? It is 3 comma 1, right? It is 3 comma 1. Now from 3 comma 2 you can go to the 3 comma 3. So parent of 3 comma 3 is 3 comma 2. Mark it as visited and push it into the queue. Now 3 comma 3, where you can go? From 3 comma 3 you can go to the 3 comma 4. So mark it as visited, push it into the queue. And who is the parent of 3 comma 4? 3 comma 3. Now from 3 comma 4 you can go to the up, you can go to the right. You cannot go to the left because this is already visited. Now you can go to the, so mark it visited, both of them, and push it into the queue. So push it into the queue, that is 2 comma 4 and 3 comma 5. Now who is the parent of 3 comma 4, 2 comma 4? It is 3 comma 4. And who is the parent of 3 comma 5? It is also 3 comma 4. Right, perfect. Now from 2 comma 4 you can go to the from 2 comma 4 you can go to the 1 comma 4. You can go to the 1 comma 4, mark it as visited, right? And we are done with this. Now we have next 3 comma 5. From 3 comma 5 you can go to the 3 comma 6, mark it as visited, push it into the queue, right? And who is the parent of 1 comma 4? It is 2 comma 4, right? 2 comma 4 is the parent of 1 comma 4. Who is the parent of 3 comma 6? 3 comma 5 is the parent of 3 comma 6. Now we have next 1 comma 4. From 1 comma 4 you can go to the 3 comma 5. So uh, you can go to the 1 comma 5. Who is the parent of 1 comma 5? 1 comma 4. 1 comma 5, mark it as visited. Perfect. Now next we have 3 comma 6. From 3 comma 6 you can go to the 2 comma 6. So mark it as visited and push it into the queue. Who is the parent of 2 comma 3 comma 6 is the parent of 2 comma 6, right? Now next we have 1 comma 5, right? Next we have 1 comma 5. From 1 comma 5 where you can go? You can go from 1 comma 5 you can go to the 1 comma 6. You can go to the 1 comma 6, mark it as visited. And who is the parent of 1 comma 6? 1 comma 5, push it into the queue. Now from 2 comma 6 you cannot go anywhere, and similarly for 1 comma 6 we are done, right? Now we have this parent array, and we have also uh, done the BFS traversal, and we saw that the B point is visited. So there is a path. Now we have to print the shortest path, right? So to print the path, we have end is equals to 2 comma 6 and start equals to 1 comma 2, right? So we have cur is equals to end equals to 2 comma 6. So while cur is not equals to start, you have to maintain result. So pushback, result dot pushback cur, and next you have to look for parent, that is cur is equals to parent of cur dot first, right? Cur dot first and cur dot second, right? So what do you have in result? So start with the end, we have 2 comma 6, then we have 3 comma 6, right? So it is updated with the parent of 2 comma 6. 2 comma 6 what is 3 comma 6, right? 2 comma 6 is stored 3 comma 6. So 3 comma 6 where it is come from, right? So 3 comma 6 is parent of 3 comma 6 is 3 comma 5. Then similarly for 3 comma 5, 3 comma 4, 3 comma 3, 3 comma 2, 3 comma 1, then 2 comma 1, then 1 comma 1, right? And after that the loop breaks out because 1 comma 2, that is equals to start, right? And uh, you have to store you have to write another statement for the start result or pushback start, right? So you have start also 1 comma 2 in this array. Now you have to reverse it. So after reversing you got 1 comma 2, 1 comma 1, 2 comma 1, 3 comma 1, 3 comma 2, 3 comma 3, 3 comma 4, 3 comma 5, 3 comma 6, 2 comma 6. And to print 2 comma 6, right? It is 2 comma 6, right? Perfect. Now to print it, you found that there is decremented in the column, then there is incremented in the row, there is incremented, then there is incremented in the column, incremented in the column, incremented in the column, incremented in the column, and incremented in the column. Then there is a decremented in the row. So when there is an decremented in the column, it means it is left, right? There is decremented in the column, that means it is left. And if it is incremented in the row, that is it is down. Then there is incremented in the column, then it is means it is right. So these all are right. And if there is a decremented in the row, that means it is up. So this is how you can print your path by using parent type. So I hope you got this. So let's code it. Now let's code it. We have n cross m grid vector string a of size n, So this is our input. Now let's define the parent array. Vector of pair int comma int, right, and parent of size n cross m, and let's initialize it with some pair minus 1 comma minus 1. Okay, so this is our parent array. Let's define visited array of size n, visited of size n cross m. Perfect. So this is our visited array. Vector, right, vector of int, visited array. Yes, perfect. Now what next we have to do, that is we have to find starting and ending position. Start comma end for int I equals to 0, I less than n, I plus plus, j less than n. Now what is the starting and ending position? If a I j is equals to a, that means it is our starting position. Yes, if it is equals to a, that is it is our starting position. So start is equals to I comma j. Perfect. Now if a I j is equals to b, then it is our ending position, I comma j. Next we have to do BFS. So let's declare q, where int comma int q, q dot push, q dot push start, and next we have to visit it, mark it visited. So start dot first, start dot second is equals to 1. Now while not q dot empty, right, while q not empty, what we have to do, we have to take the x, q dot front dot first int y equals to q dot front dot second, right, and we have to explore all the equation. That is something that I had already explained in the previous video. K equals to k less than 4, k plus plus, right. Next x is equals to x plus dx of k, and next y is equals to y plus dx dy of k. So this is our direction vectors to explore all four directions, right. Now we have to check are they in the bound or not. So nx is greater than equal to 0, nx is less has to be less than n, ny greater than equal to 0, and ny has to be less than n, right. Now if it is in the bound, I have to check if it is floor or not. It has to not equal to wall. If it is not equal to wall and not visited, if it is not visited, then what I have to do, I have to push it into the queue, nx ny, and mark it visited, nx ny is equals to 1, and uh, store the parent value, right, parent value of nx of ny is equals to x comma y. So this is something that you have to do. This is BFS, right. Next we have to construct our path. Now if visited and dot first and dot second is not equals to visited, then there is no path, right, then there is no path. Else we have to construct our path string path is equals to t. Let's make the empty string. We have to make result the pair int comma int result, and we have to make a cur which is equals to end. Now while cur not equals to start, what we have to do, we have to store it into the push back cur, right. And next what we have to do, we have to update the cur equals to parent of cur dot first and cur dot second. Perfect. So this is how you can construct your result, and we have to insert a start also. Push back start, then we have to reverse it. Reverse result dot begin and result dot end. Then we have to construct our path, right? So there are four cases, right? Int I equals to 0, I less than result dot size minus 1, I plus plus. So there are four cases, that is incremented row, decremented column, right? And incremented row, decremented row, incremented column, decremented column. So for this is the row, ith row, and this is the next row, right? I plus 1th row, and this is ith column, and this is ith I plus 1th column, right? So there are four cases. One else, yes, this is else if, and this is else if. Perfect. So if it is incremented row, and if it is decremented row, if it is incremented column, that is this, and there is decremented in the column. So if it is incremented row, we have to add path plus equals to incremented row, that is it is down, right? If it is uh, path plus equals to, if it is decremented, that is it is up, right? And if it is incremented in the column, it is right. Path plus equals to right, and otherwise it is left. Path plus equals to left. Perfect. This is path PDH. Perfect. Then we have to print what? Print path dot size, and we have to print path itself, right? So, and we have to print yes also, means there is a path. See out, yes. Perfect. This is the code. Now let me check once it is all correct or not. So we declare nm, take the input, and we have a vector of a string. We take input, we have a vector pair of pair int comma int parent. Perfect. Then we have a vector of visited array, that is also correct. Then we have pair int comma int start end. Then we found the start position and ending position. Yes. Then we declare a queue. Then we push start position. We mark it as visited. If not queue empty, we take the x and for y, and we explore all the positions, left, right, up, down. And if it is in the bound, then what we have to do, we have to, if it is not full, if it is not visited, then we push it into the queue, we mark it as visited, and we store the parent value. Next, if ending position is not visited, it means there is no path, and then we print yes. Then we have to construct path. For this we maintain a result, we have current equals to, and then we make a result, and then we construct our path. Perfect. Right. Now let's try to run it. I hope it's correct. Let's try to run it. There's a mistake. 4 4 4 in the line 17. Yes, it has to be 4. Perfect. Let's try it again. 4 int. We forgot int. Yes. Perfect. Let's try it again. My bad. We have to pop out also. I think this mistake here. Q dot pop. We have to pop. Let's try it again. I hope, yes, this gives us right answer. That is 9, and this is the path description, right? And the time complexity of this code is going to be n cross m, and space complexity is also n cross m, right? I hope you understood it. If it is not the case, comment it down. I try to resolve your doubts. Thank you.